In this lesson, we will learn the basic idea of limits, the properties of limits, and solve a few model problems step by step. Let's start with the definition of a limit. The notation reads, the limit as x approaches of f of x equals L. This means that as x gets closer and closer to a, the function values get closer and closer to L. Let's visualize x approaching on a number line. Here is the number line with a marked point A. We move x closer and closer to a from the left and from the right. Now, let's look at some important properties of limits. These let us break complicated expressions into simpler ones. First, the limit of a sum is the sum of the limits. Second, constants can be pulled outside the limit. Third, the limit of a product is the product of limits. And finally, the limit of a quotient is the quotient of limits, as long as the denominator limit is not zero. Let's solve a few model problems. Example 1. Find the limit as x approaches 4 of 2x plus 3. We can substitute directly. 2 times 4 plus 3 equals 11. Example 2. Find the limit as x approaches 1 of x squared minus 1 over x minus 1. This is an indeterminate form, so we factor the top. Then we cancel the common factor. Now the limit is just x plus 1, and at x equals 1 it becomes 2. Here is a quick graph of x plus 1. Notice the whole at x equals 1, but the y value it is approaching is still 2. That matches our limit. Example 3. The limit as x approaches 0 of sine x over x. This is a famous limit, and it equals 1. Let's look at the graph near 0. To summarize, a limit describes what value a function approaches, even if the function does not equal that value at the point. We learned the basic definition, key properties, and solved several examples.